how many whole numbers are less than 10,000 that start with 2 prime digits? First things first, we got to talk about prime digits. So we've got 4 numbers in anything that's less than 10,000. Because remember, the highest we can go is 9,999 if we are less than 10,000. What digits are prime? Prime digits are numbers that can only be divisible by 1 and itself.
So it's
2, 3, 2, 3, 5, 7, and what's the other one? There's one more.
9.
9's divisible by 3. I think somebody said it and I just missed it. 1. They're digits, so they're just one number.
Oh.
Okay. So 1, 2, 3, 5, and 7. So that means I have how many choices for this first number? 5. I have 5 prime numbers. My second number also needs to be prime, so how many digits do I have to choose from? 5. It doesn't matter what these last 2 are, so how many numbers do we have to choose from?
5.
10. From 0 to 9 for these last ones. The only restriction I had was starting with 2 prime. So I've got 10 options here and 10 options here, which gives me a total of what?
A number.
Yes, a number. 2,500. Okay. How many whole numbers that are less than 10,000 contain no 3 or 5 digits? So again, you've got 4 numbers that become less than 10,000 because your highest you can go is 9,999. So this can contain anything except 3 and 5. How many choices do I have? 8. Guess what? All of them have that same restriction. So it's 8, 8, and 8. 4,096. And finally, the last one, how many whole numbers that are less than 10,000 contain any 3 or 5 digits?
2 times 2. Oh, wait, no.
Not necessarily.
4.
What if I give no restrictions? What's that total?
10.
Times 10 times 10. Whoops. Taking my recycling box. Okay. No restrictions is everything. I've got 10 options, which gives me a total of what?
10,000.
10,000. So if I have 4,096 that contain none, the opposite of 10,000 will contain any. So we subtract the 2 here. So I actually have 5,904 options that can contain any 3 or 5. Questions? Consider all of the numbers from 10,000 to 99,999. Good. So, how many digits, how many numbers do I have if I'm in between 10,000 and 99,999? Okay, the last one we had 4 numbers. How many do we have now?
10,
10.
8, 9.
5.
What am I 5?
I'm talking about how many spaces you have available for your numbers. Okay? Because remember, less than 10,000, your highest number we could go to was 9,999. So we only had 4 spaces. We only went to the thousands. Now we're talking in the 10,000s. Okay. All even digits. Notice your first digit must be between 1 and 9. So how many even numbers do I have here in between 1 and 9? 4. Okay, everything else we're throwing 0 back into the mix. And yes, they're considering that as an even number. So what options do I have for the last 4? 5. Because it can be 0, 2, 3, or 2, 4, 6, or 8. No matter what.
25,000.
2,500.
I mean, my bad, 100.
2,500. How many numbers contain the first and last digits that are odd? So again, I still have up to the 10,000 space that I have to fill in. This has to be odd. This has to be odd. The rest of them have no restrictions.
So 3.
So how many numbers are odd? 5. 1, 3, 5, 7, 9. There's 5. So these are both, I have 5 different options to fill those spaces.
Yeah, 10, right?
And everything else should be 10. There's no restrictions. Your odd numbers. 1, 3, 5, 7, 9. You have 5 options to fill that spot.
50. Now it's 25.
Okay. Now it's 25,000. How many numbers cannot contain a repeated digit? Okay. Be careful with this one, because we're still talking about the fact that the first digit has to be anything 1 through 9. So this can be anything 1 through 9. So how many options do I have here? 9. We're not counting 0. These can be anything 0 through 9. No.
So 10. No, it's still
7.
It's going to have to go down. However, let's say this is a 1. That takes 1 out of here. I can't use it, but we also plug back in
10.
0.
10.
0.
So it's 10.
So no,
Oh, it's 9.
it's 9 again.
Wait, what?
Okay, so hold up. So let's say we pick a 5 for here. Okay. My options were 1 through 9, and I picked a 5. Now my options are 0 through 9. 0 through 9 altogether have how many numbers?
10.
10. If I've taken away 5, how many options do I have?
5.
9. How are we getting 5? Zach, I need you to just stop, because you're just randomly shouting
That
out.
one's 0. That one's 0.
Alonzo.
That was me, sorry.
Oh, I sound.
It was called.
It's not funny, Alonzo, because
Sorry,
you're going to
sorry.
get everybody else confused.
Sorry.
It's not funny.
No.
Okay. So if I have the numbers between 1 through 9, 6, 7, 8, 9, and I take away 5, I now have 9 options again. Don't forget though, with this first one, I only had 9 options because 0 wasn't an option yet.
Oh, okay.
So I've
Different
taken
options.
1 out, but I've thrown another number back in. That's why you have 9, 9. Does that make sense?
Yes.
Okay. I just wanted to clarify that before I lost you all. Okay. So 9, 9. Now it starts to go down.
Yes.
So now we're at 8,
7.
7, 6. Okay. $27,216. The last one. How many numbers contain all of the same number for its digit? Okay. So again, my first number can be anything from 1 through 9.
9.
So I have 9 options. Okay. I want every other number to match this one. So how many options do we have for every other space? 1. Okay. If I pick a 7 here, I only have 1 7, 1 7, 1 7, 1 7. Options to have a number that's like 2 2 2 2 2. Okay. Because once you've picked that first number that you have 9 to pick from, you only have 1 option the rest of the way. Does that make sense? Okay. So, Alonzo,
Yeah, I get it. I get it.
you just told me you didn't.
No, I did.
Okay.
Just kind of I did.
Okay. Moving on then. A committee is to be chosen from 8 scientists, 7 psychics, and 12 clerks. If the committee is to have 2 members, of different backgrounds, how many such committees are there? So I need 2 different backgrounds in a committee. So my first committee can consist of what? Scientists and psychics. Psychics. Or what else can I pair together? I need 2 members of different backgrounds. Scientists and clerks. Or psychics and clerks. Okay, so let's look at this as numbers. Scientists. 8 and means to multiply. Psychics. 7 or plus. Scientists. And clerks. 12 or. Okay, 7 times. Perfect. Okay, you have to pair each one of them together. Just like we did with the quarterbacks, linebackers, and wide receivers when we did the football problem. $236. Okay? Number of different outcomes to flipping a coin 4 times. So the first flip, we have how many options? 2. The second flip, I have how many options?
2.
Third flip. 4th flip.
2.
Total of 2 times 2 is 4. 2 times 4 is 16. Good. Total of 16 different ways, 16 different outcomes. Again, you can write that as 2 to the 4th. How many true or false answer keys are possible for a 4-question test? Question 1. How many options do I have? 2. Question 2. 3. 4. Whopping 16 again. Okay. A pizza place offers a special on Saturday nights. Starting from cheese pizza, customers can choose from 4 different toppings: pepperoni, mushroom, sausage, and olives to make a pizza. How many different pizzas could be made? Okay. This is a little bit different. Instead of telling me we're going to put pepperoni, mushroom, sausage on a pizza, you're going to tell me yes or no, do you want pepperoni? Okay, so you've got 4 different toppings. You've got pepperoni, mushroom, sausage, and olives. If you get to say yes or no to a topping, how many options do you have for pepperoni? 2. I can say yes, I want pepperoni, or no, I don't. I can say yes or no to mushroom. 2, 2, and 2. I have 16 different ways I can put together a pizza with 4 toppings. All of those questions were quite different. However, all came out with the same outcome. Okay, we're almost done with this section and we'll move on to permutations. A password is 4 characters long. 1, 2, 3, 4. First character must be a letter. The last number must be a number. So we need a letter and a number. Password is not case sensitive, which means upper and lower case are considered the same. So I can put an uppercase L or a lowercase L. So how many letters do we have to choose from? 26. How many numbers do we have to choose from?
52.
Numbers. Down here, 10. Okay? In between, I can pick a letter or a number. So I have 36 options. Perfect. Bam. What do we get? Perfect. 336,960. Okay? We're talking about the same code, except But your password is now case sensitive. So that means I have how many options for a letter this time? 52. Because your lowercase l and your uppercase L are two different options. So I have 52 options. I've got twice the amount I had before. I still have 10 digits, which means the spaces in between, I have how many options? 62. And you should end up with 1,998,880 different options. We've got two more problems to finish out this section.
Then we on to the next.
And we on to the next. Permutations.
On to the next. On to the next.
Can I go get some water?
Did you really think it was 7 o'clock?
I mean,
What about it?
yes, please.
Oh, stop.
Okay. A student college ID contains 8 digits to a meal plan. A 4-digit PIN code gains student access to recreational facilities. And an email password contains 6 characters that can be digits or letters that are not case sensitive. What is the total number of passwords or IDs that a university computer must be able to hold? So, first thing we need to talk about is your ID. Your ID contains 8 digits. How many digits do we have to offer? 10 available digits. I'm offering 8 of those, so 10 to the 8th power. I've got a PIN. They've got a PIN. It's a 4-digit PIN code. Again, how many digits do we have to offer? 4 or 10. And I'm filling in 4 different digits. So it's 10 to the 4th. And finally, we've got a password that can be letters or numbers. How many options do I have? If I can do letters or numbers. 36. How many spaces do I have to fill in for that? 6. So we raise it to the 6th. You would get those 3 answers and put them all together. So you would add all 3 of these up. 2,792,336. That's a lot of memory for a computer to hold.
Sheesh.
Okay.
336.
Wow.
Okay. How many 5-letter words either start with a D or do not have the letter D? So we have to do both separately. We start with a D. We're doing 5-letter words. Okay. This letter has to be a D. How many options do I have? 1. Okay. Everything else can be anything. So how many options do I have? 26.
Oh.
It's not saying once you use the D, you can't reuse it. Okay, so I've got 26. Okay. Now we need to do no Ds. So none of these can contain a D. How many options do I have? 25. I have 25 letters that are not Ds. And again, you would add these 2 answers together, and you get 10,222,601. Okay. Your biggest thing, your biggest challenge is going to be figuring out what in the world are they asking of me. If you can decipher that, this section becomes very easy. Okay, we're gonna skip the warm-up problems. And we're gonna move straight into permutations. Permutation means order matters. Okay, so something like you're picking president, vice president, secretary, treasurer. Okay, order matters. If I pick Emil first, he's gotta be president. Okay, if I pick Chris second, he's gotta be vice president. So order is going to matter here. Big thing, this is how you tell the difference between combinations and permutations, is order matters. Permutations, also, there is no replacement. So once I pick Emil, I can't pick Emil again. He's one person, he can fill one spot only. So, permutations, an ordered arrangement of objects from a group of objects. So, go back to the one where we said we had 6 candidates running and I needed a president, vice president, secretary. So, how many people did I have to pick for president? 6. I want to pick one person, but I have 6 people to pick from.
Okay.
When I moved on to vice president, I then had 5 and 4. So, permutations will always be the ones that go down. That's all this means. If I start with 6, then my next number is 5, my next number is 4, my next number is 3, so on and so forth. Do not let this confuse you. That's all that's saying, is it's going down every time. Okay, here is your formula. I will also show you where the permutation button is in your calculator. However, there is a section on your test where I need you to put it into a formula. So if, for instance, if we had something like 7 permutate 3, okay, this means I have 7 people to choose from and I've got 3 spots to fill. Okay, so my first spot I would fill, I have 7 people to choose from. The second spot I have 6, and the third spot I have 5. I would stop there because I'm only filling 3 positions. That's what that means. Okay. So I have 7 people to start with, and I'm only filling 3 positions. So we start at 7, it goes to 6 and 5. Yes, ma'am.
How did you know that?
How did I know that this was a 7?
No, for the that over there.
This?
Yeah.
I made this up.
Oh, okay.
I made this up. So if we had something like 7P4, okay, we'd start with 12, 11, 10, 9. Okay, you've got 4 spots to fill and you start at 12. Okay, that's it. That's all permutations are. We're going to deal with stuff that looks like this.
Oh, so
When it says use a formula or a multiplication statement, this is where I want to see what you're doing. So 6 permutate 2.
what would be 6
So
times
6 times 5, which gives me a total of 30.
100.
Okay, down here, 6P4.
6, 5, 4, 3.
6, 5, 4, 3. And that is going to give you a grand total of, I guess it would help if I grab the right paper, 360. Thank you. 100. Permutate 1.
Is it only 99?
That's just 100.
Oh.
I started 100. I only need 1 number. You're done. 10. Permutate 9. We started 10, 9, 8. When do I stop?
At 2.
At 2. Times 3 times 2. That's 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm done. 3,628,800. It's a lot of numbers to multiply together. 4 permutate 4.
For all numbers.
It's all of them. 4 times 3 times 2 times 1. 24. And 13 permutate 5. 13, 12, 11, 10, 9. Perfect. And you get 154,440. Just so you can see where to plug this into your calculator. Let's do part D in your calculator. I want you to type in 10. I want you to then hit math. Scroll over to probability where you see PRB. And it's choice 4. Okay, that's your P. You'll see NPR. You hit that, and then put 9, and hit enter. And you should come out with this answer right here.
Yes.
If you did not, please raise your hand and let me come and work it with you. It's 10P9. You put 13.
That answer didn't equal.
You didn't do your permanent. You did the factorial. Is it choice 2? He told me 4. I was listening to him. No. Okay, it's choice number 2. See where it says NPR? I already put 10 in, so hit that. And then you would type in 9 and hit enter. Okay? This, but you can always check yourself in the calculator. Okay? And make sure it's correct. Okay. Consider the letters A, B, C, D, E, F, G. How many 4-letter words can be made? So we're going to see the difference between what we've been doing and what we're about to do. So letters can be reused. Okay, I need a 4-letter word, and all of my letters can be reused. I have 8. I have 8 different options. 8 times 8 times 8 times 8. So if everything can be reused, I should have a total of 4,096 options. Part B. You can either write it out or you can permutate it at this point. Letters cannot be reused. First option, I had 8. 7, 6, 5. Another way to write this is 8, permutate, 4. I started at the number 8. I want it to go down every time, and I want 4 spaces to be filled. So 1680, perfect. And finally, no repetition, but D is your last letter. So if D has to be my last letter, my last one has how many options?
1.
1. Okay? How many options do I have for the first one?
7.
Why 7? Because I've already used D in the last spot. So 7, 6, and 5. Fantastic. There's 210 options. Example 3. 7 candidates are planning to interview for a job, but there are only 4 interview slots. 1 p.m., 2 p.m., 3 p.m., 4 p.m. with the company. How many different interview schedules can the company create? Okay, so when they're starting to give you detail like this, that means permutation. If Alonzo goes in for the 1 p.m. interview, he's not going to go back and do the 4 p.m. interview. So there's no repetition. Okay, so how many total candidates do I have to pick from? 7. How many slots do I have to fill? 4. 7. Permutate. 4. 840. So it's always the total and how many you're going to pick. A car's new stereo has a 6-slot CD changer labeled 1 through 6. CDs that he regularly listens to. How many ways can Jeff put his CDs into his new car stereo system? What does this look like as a permutation? 20
P6.
P6. Another way to look at it, your biggest number should always be on the outside. Okay? If you try to do it the other way, it's going to tell you error, error, error. Doesn't work. Okay? 20 P6. 27,907,200. That's a lot of ways your car can shuffle those CDs. We only have 1, 2, 3, 4 more examples, and we can stop for lunch. Okay, 4 more.
These are short.
A passcode is 8 characters long with no repeated characters, but the first 5 characters have to be lowercase, and the last 3 characters must be a number. So we take this into 2 different things. Okay, we need to talk about the first 5 characters being lowercase letters. How many lowercase letters do I have to choose from? 26. Permutate. What comes after that? 5. Okay, 5 of them have to be lowercase letters. So 26, permutate, 5. Times 10, permutate, 3. Perfect. Okay, I have 8 total characters. So 5 plus 3 must give me 8. That's how you know you have it all covered. The 5 are letters. We have 26 options. The 3 are numbers. We have 10 options. If we plug that in, you get 5,683,392,000 different passcodes.
Even when the bottom is so little.
4 people are running for president, vice president, treasurer, and secretary. How many different ways could these people hold these 4 positions? Again, when it's specific positions, think permutations. So, how many people do I have to choose from?
4.
How many positions do I have to fill? 24. 4 permutate 4, 24. Last 2. On the first day of class, 30 students find themselves in a classroom with 30 desks already arranged for them, but no seating chart has been made. The teacher gives the students free seating and will write down the seating chart afterwards. How many different seating charts are possible in this situation? Why is this permutation? You can only take 1 seat. Okay, so if Rebecca sits in 1 seat, nobody else can take that seat. So, what's my starting number? 30. What's my ending number? 30. Okay, you're going to get 2.65 e to the 32nd. When you get something like that, just leave your answer as this. I'm good. Okay. When it doesn't give you a straight up answer, just leave it as permutations. It's fine. Consider the set ABC. How many different 3-letter words are we allowed to make without repeating a letter in the word? 3. Permutate. 3, because I'm making a 3-letter word. 6. They're not going to make any sense, because ABC is not a word, but you can spell cab. That is a K. Proper English, my friend. Why can't a permutation be used to find the result of 3 consecutive flips of a coin or 4 tosses of a dice? You can get the same one back to back. If I flip a coin, I can get heads twice in a row. I'm not eliminating anything. There cannot be any repeated. Okay. Questions or problems? When we come back from lunch, we will start with combinations.
What about homework?